Welcome to Honeycon, our first ever user conference. We couldn't be more excited to have you all here with us today. We've got some exciting new announcements for you, some very shiny new features, and a fantastic agenda all about how our community has used Honeycomb to be awesome at production. To kick the day off, given the Honeycomb focus, I thought I'd share a little bit about how we got here and the experiences and philosophy that underpin what Honeycomb is today. When Charity and I first met back in 2012, our first few interactions at work looked a little something like me as a new dev, new to the team, shipping some new component or feature, and her, the tenured ops person, grudgingly working with me to get my new thing production ready. At the end of that process, she would point me at some dashboard and say, okay, this is the one to watch to make sure everything will be okay. And I would nod and be like, okay, ready for production. What I didn't admit to her was that I had no real confidence that I would know what to do if a graph started looking funny. I was pretty unfamiliar with shipping software at that scale. And honestly, I was embarrassed. She seemed badass, so did all the other ops people, and I was the new dev on the team. Unsurprisingly, when things did start to go sideways, I was not helpful. I would mimic the ops folks and scroll through the dashboards like they did, but I didn't know how to map those graphs back to my application logic. They were talking about ops things like Cassandra write throughput. I was trying to figure out how to reproduce the problem locally and construct a test case and deploy the fix. You know, dev things. We eventually found the issue, sometimes slap a Band-Aid on it, and we'd move on to the next problem. Neither side was really having fun working with the other, but we kept the lights on, you know? When we were acquired by Facebook, one good thing that happened was that we started using an internal tool that eventually became the inspiration for Honeycomb. And it didn't quite look like any of our previous logging or monitoring tools. It let us throw all sorts of data into it without having to worry about strict schemas or cardinality. And before long, we found ourselves using the same tool, happily this time, to look at production. She was able to use the tool for traditional purposes since she and her team still owned infra. But I was using the same tool to support the service I'd built, trying to dig and understand why my code was behaving strangely for some customers and not others. With the benefit of hindsight, one might notice that those are the same behaviors, just on different timeframes and with different levels of pressure. And without us really trying, once we were able to use one tool to combine her nouns, write throughput, hosts, memory utilization, with mine, deploy ID, user ID, API endpoint, we were using the same tool for everything. When we first started Honeycomb, we thought we were only building it for the giant systems of the world and the charities out there, carrying pagers, dealing with the pressures of being on call. But within that first year, we realized that actually we were building for everyone because everyone is dealing with these problems of understanding production. And not only is dev buy-in necessary for instrumentation, capturing stuff that matters to the application logic, getting dev buy-in makes Honeycomb and observability as a whole better because everything is served when devs feel better and more comfortable in production. Everyone is served when devs and ops can share ownership in production. So we reset our spot on the spectrum from hard ops to somewhere between us. Because these roles are blurring, have been blurring. And since then, Honeycomb has been built for teams who recognize that, who want a tool to facilitate that blurring of boundaries, and who want to create that shared language across dev and ops. We made a set of early predictions and bet the company on them that have only been confirmed over the last 5 years. First, the complexity of systems has in fact only increased. Yes, there's been some backtracking, some macroservices instead of microservices. It's all more complicated than it used to be. more top engineering teams have in fact started putting developers on call. Like Outreach, whom we heard from yesterday about the lessons they learned, putting their 200 developers on call. We knew custom instrumentation would be key, and automating away the baseline work would be a part of that. OpenTelemetry has really paved the way here for vendors to build a better, more portable, and more customizable future. And finally, this one's still on its way, but we thought developers would start to think of production as an extension of their development environments. Still in its early days, but for anyone who caught yesterday's talk from Michael Haberman, a dev and CTO of Aspecto, it's happening. At our very first hnycon 3 years ago, we included a set of open spaces where attendees could come together and discuss what observability meant to them. Our goal was to come out of the day with a clear definition of what observability could mean for the future and share our emerging best practices. Today, we're not debating definitions of observability anymore. It's about damn time. The industry has embraced it, the analysts have blessed it, and real teams are seeing real results. It's not all about the promise of observability anymore, but demonstrated results. So finally, we don't all have to include a 5-minute digression in the start of our talks about how it's different from monitoring or the various data structures we'll use. Instead, we can have more fun conversations. We can take the word observability at face value. What new ability did our teams gain today by being able to see into production? How do we level up at that ability? Which tools can catalyze these abilities? Which processes can support these abilities? And what sorts of engineering cultures supercharge these abilities? And how do we ensure our ability to deal with complexity keeps up with the times? I know one way of dealing with complexity that doesn't work, doubling down on what used to work. Instead of 3 dashboards, bulleting to 30. Building more runbooks, defining more time series. We've seen that world. Some of us have lived it. It ain't pretty. The other approach is the one that we've talked about nonstop on stage for the first 3 years of Honeycomb, accepting that we've left the world of known unknowns behind, and the only way forward is to embrace that chaos, to embrace the unknown unknowns, and instead iterate and explore our way to clarity. Only reasonable way to do that is to foster attitudes that make our engineering teams better, so they learn to think about and anticipate the weird stuff happening in production. Being curious, that willingness to frame questions like humans and dig into that funny spike on a graph, and examine our assumptions. That's the way forward. That's how we deal with unknown unknowns. And that's what we're seeing more and more of today as folks adopt observability. The ray of hope here is that behavior isn't brand new for most of us. We humans, we engineers, are great at exploring a problem and asking new questions and iterating on a hypothesis. It's a very human behavior at the core of this new ability, this ability to observe and understand production systems. And it's wonderful to see old school ops and old school devs alike recognize that they can and will and should learn to explore the production software like this too. That's the part that has to happen outside the computer anyway. Under the hood, there are a few technical requirements that have been core to Honeycomb's architecture that are uniquely capable of unlocking those human behaviors. First, support for arbitrary combinations of high cardinality data. You should be able to capture data that describes your business, your customers, your configuration in a way that makes sense to your engineers. You shouldn't have to predict ahead of time which attributes will be important alongside other attributes so that you can build indexes on them. Effective debugging can't rely on predefined, pre-generated lines of investigation. That arbitrariness and flexibility is key. Second, near instant query performance. Humans have shorter attention spans than ever these days. Science has said it, and thus it must be true. Investigating something in production can often feel like a mystery hunt. You're going from one clue to the next, looking under rocks, occasionally backtracking. Each of these clues is the result of a question that we ask. And if the question doesn't come quick, we might move on to something else. And it's easy to give up and sweep remaining questions under the rug if it's painful to keep investigating and the crappy answer we've got seems good enough. So within Honeycomb, our query performance is a point of pride because we know it's key to ensuring our users are willing and excited to keep digging and get to the truth. Speed and flexibility. When you boil it down, the ingredients for facilitating observability aren't so complex after all. Your engineers do, and will always, understand best how to sniff out what stinks in your production systems. So a tool that allows them to be more themselves, to do their investigative work more effectively, just needs to be fast and fit to them. One of the most exciting parts of growing with our customers is seeing what happens when they're first armed with Honeycomb versus what happens after they've had a chance to grow with it and meld it with existing workflows. Everyone starts with incident response use cases, debugging hair on fire problems, reducing downtime. But once folks are able to catch their breaths, the thought pops up. Hey, what if we shift some of this work to be a little more proactive? Can we measure performance in this experimental size of production? Can we use Honeycomb to understand and anticipate problems in this component we haven't actually technically released yet? When you start to build up this ability to ask new questions, to be curious, to iteratively interrogate your systems, you start to realize that the skill set that can be applied to any point in the development process. You add new instrumentation, gather new data, and your questions evolve over time. That is the promise of observability. It's that drive, that curiosity, that ability to understand not just how your applications and infra are behaving today, but how to make your software perform better tomorrow. If you look at the product Honeycomb has built and continues to build, you'll see that these core beliefs are manifested in the experience we craft for you. We obsess over query performance because we know it impacts how you use the tool. So we dug through the heck out of Honeycomb ourselves to try and keep to sub-second latencies for our median query. We want to make exploring production data feel like playing with a hypothesis in your brain. So we open up all the dead-end graphs that have frustrated us in the past and make sure that you can always stick your hands into any graphs you want. We never want to punish you for hitting a dead end. So we offer things like a query history, infinite undo in that query history, and actually permanent permalinks that you can access forever. We want to make it easy and intuitive to reuse past work. So we leave breadcrumbs of interesting queries all over the place for you to jump off from, whether from your teammates, or just your past self. And we optimize for you sending the data that matters to you. So we talk endlessly about the value of high cardinality data like build ID or customer ID and ensure that you can send whatever new fields are important to you today. In the early days, people liked to tell Charity and me that we were being too idealistic about the change we were trying to affect in engineering teams. That all people wanted were better dashboards. But we've never lost sight of the importance of that very human side of understanding production systems. We've tried to build a reality that would allow all of you wonderful humans to be able to do just that, to be your clever, intuitive, contextual, exploratory, engineering human selves. People don't just want better tech. That's not enough and never will be. Not at the rate of change our world is changing around us. To borrow another phrase from Charity, the future of software is a socio-technical problem. Technical advances unlock human behaviors, and human and organizational tendencies necessitate technical change. The social and technical are interwoven, not simply two distinct halves of a whole. So we've built technology and a product for you, the industry, you humans, to use. And over the years, this is what we've heard you've done with it to reduce toil for your teams and delight your users. You've made on-call suck less. Honeycomb helps your engineers resolve incidents faster by being able to tease apart specific requests rather than trying to understand only performance in aggregate. You've made your customers happier. Honeycomb allows you to make performance a priority and feature of your product and to optimize every aspect of how your software runs. You've built feedback loops into all sorts of production adjacent processes. Honeycomb plays nicely with CI/CD, chaos engineering, progressive delivery, among others, so that you can embed observability into modern tools in your existing workflows. And you've built high-performing teams. Honeycomb helps teams pinpoint areas to improve, transfer knowledge, and ship fewer breaking changes in the first place. It's been pretty incredible. So that's what you'll hear about later today. That's what Honeycomb is all about, after all, hearing from real customers. But I promised you some new shiny. So Liz, would you walk us through what all this looks like from an engineer's perspective? And maybe show off some of our new releases along the way?
Thanks, Christine. I'm really excited to be here at Honeycon with you all today. Hi, I'm Liz, and I'm an engineer at Honeycomb. And today I'd like to show you what Christine means when she talks about designing for curiosity with features that are fast and fit both developer and operational needs. We're going to look at what it means in practice to reimagine the workflow of releasing software to production. I'm going to show you how we release software at Honeycomb and how we debug it and how that differs from other places that I've worked before. Because in a previous life, we did big bang releases. We only shipped software about once a month in big batches to production. And we wrestled with having many different release branches. We spent hours rolling back any time misbehavior turned up in prod. And we struggled to diagnose subtle performance problems, such as individual users having a slow or erroring performance. Now, it's true that companies have gotten better at performing small batch releases more frequently. But moving faster doesn't necessarily translate to more safety. There's often no real confidence that deployments are truly production ready, and engineers don't really have a good understanding of how their changes are going to behave in production. So we're packaging up and shipping changes to production often and automatically, but the net result of unreliability and distrust of production is the same. Because if issues happen once that feature reaches production, with older tools, it's still difficult to diagnose exactly why those issues are occurring, and we often have to roll back as the only way to fix the problem. But fortunately, we're able to move much faster and more reliably at Honeycomb. We practice continuous delivery, and we integrate observability into our entire software development lifecycle, and we call this observability-driven development. So today, I'd like to show you how I modify, release, and debug new Honeycomb features that we're shipping to you all in production by using a second copy of Honeycomb. I'm going to be showing you how instrumentation, build, service level objective, querying, metrics, and collaboration features all combine together to make for a fast and reliable developer experience that empowers our developers to have curiosity and understanding. So let's show you Honeycomb's Query Data API. It's a new feature that's being released today that allows you to run Honeycomb queries programmatically and obtain results as data that you can integrate into your workflows any way that you see fit. So for this demo, I'd like to show you how I can make modifications to that new feature. Let's suppose that I want to improve the freshness of results for beta customers of the Query Data API. Let's go ahead and cache their results for less time so that they can get fresh data every 10 seconds, not every 10 minutes. And let's allow them to do that, not just for 24 hours of data, but for an entire month at a time. So we're changing these parameters, and we're adjusting the handlers that handle query, rate limiting, and caching. So we're going to kick off a pull request that will test and build this change before we release it to production. And then Circle CI will go ahead and start building my software. Now I can follow what's happening inside of the Circle CI UI, and that'll give me the web of dependencies, but it doesn't tell me what's happening at what time, what happened when. So instead, let's look at the build jobs as a trace inside of Honeycomb. When we look at that view, that enables me to understand why my build is unusually slow and what the slowest part was. And this is something that Honeycomb build events enables, and it integrates for us with a Circle CI org, but you can also use GitHub Actions or just run a shell command inside of your build pipeline. So once my build is finished, I can go ahead and think about releasing it to production by clicking on the merge button. But wait a second, let's make sure that it's actually production ready. So at Honeycomb, what this means is that I want to have enough telemetry baked in so that I know how my production services behavior is changing and which users are impacted. If the performance is negatively impacted for any reason, I need to know what I'm looking for inside of the prod code. So let's review how we measure and understand success. With OpenTelemetry, we've added custom instrumentation fields like cache hit miss, our team and dataset IDs, and we have inner spans for every individual function call that might take a lot of time. And this is all in addition to the automatic instrumentation that OpenTelemetry adds on every API request. So these bits of telemetry tell me how the caching performance has changed and who that change is impacting, and if there are any errors. Additionally, we also have service level objectives set for all of Honeycomb, as well as for this specific API service. So we've defined what the success criteria are for our beta customers who are using this new query data functionality. So in this particular case, we would like query API data to return in fewer than 2 seconds. If results take longer than 2 seconds to return, that's a bad experience for Honeycomb customers, and we want to count those queries against our error budget. Remember, slowness is the new downtime. Of course, we've also zoomed out and looked at all of our service level objectives just to make sure that everything is in a good state before we push any releases. So as a developer, I've clearly defined success and failure criteria for how my change is going to impact production. I know where in my code I can look if I encounter any problems, and I understand the state of production before my change is introduced. That is what it means to be production ready. Now at Honeycomb, it's my responsibility to watch how our changes impact users in production. And when I ship, I'm expected to look at production behavior alongside whomever is on call from engineering. So our observability-driven development approach really helps us with being able to understand code changes as they're rolled out with the help of great tooling like Honeycomb. So having prepared to observe the results, now I can hit the merge button and my change is built within 10 minutes, and it automatically gets shipped to all of our environments within an hour. So let's go ahead and wait an hour and see what happens. Well, that's less good. Within an hour of my change shipping, the reliability of the query data API has really taken a nosedive. So that's unfortunate. The good news is that we found out before we exhausted our entire error budget because we got a burn alert that told us proactively. So the engineering on-call and I both start looking because they're on call for the service as a whole, and I'm responsible for watching my specific code. So we can see that there's been a dip in availability, and Honeycomb points out what factors are contributing to unavailability, which properties are shared between all the failing requests that happened after my code was released to production. Because I want to understand, why did my code fail, and why didn't this turn up in pre-prod? So Honeycomb's integrated bubble up feature helps us understand what keys and what part of the key space is broken. So you can see a few things. First of all, the heat map lets us see that a majority of the queries are still faster than 2 seconds, but some are a little slow, and that's a bad customer experience. We consider that a failed query. We can see that all of the slow queries come from 3 specific partitions, from 1 or 2 specific build IDs, and they all have a very high number of results being returned, a high number of result groups. So this really helps me drill in and understand what are the common factors of performance that are happening here, and how might I be able to stop this SLO burn from happening. So let's drill in even further and get a record of this customer's queries using the query data API on this specific data set. Now, as you can see, there's only maybe about half a dozen customers here with early access to the query data API, but I could as easily have plotted across all Honeycomb queries being run across tens of thousands of data sets. It doesn't really matter. Honeycomb can query and group by any arbitrary number of cardinality fields and query across arbitrarily many of them as well. So let's go ahead and have a look at the performance for the specific data set. And let's also maybe zoom out and group by dataset ID and have a look at all of the data sets together now that we've examined how recently this behavior started happening. So let's use Honeycomb's new time comparison feature, which allows us to understand how this customer's queries and all of the queries against this API have performed day on day or week on week. Is it that this customer is ramping up and this is a normal behavior during a weekday? Or have they suddenly started sending us more queries than normal? In this case, we can see that the customer that is seeing slow query performance is suddenly flooding us with a lot more queries, and that we're not getting cached results. We're doing fresh work every time. So we're able to compare day on day and week on week and see what's happening. But just to make sure that it's not just this one customer, let's also have a look at what's going on with the other customers. Now, I'm going to note that there are a lot of other customers on this graph. And we may not necessarily want to look at all of them because there are a few customers here that have sent one query in the past week, and then they've gone away. They haven't really sent us another query using the query data API. So what if I could declutter my graph and get rid of all of those things that don't necessarily matter for this particular investigation? So that's where it would be really helpful to use Honeycomb's new halving clause feature. So that lets us focus only on the relevant time series and allows us to remove that clutter and show us only groups that have, for instance, let's say 2 results at least that either succeeded or ate into my error budget. So I'm going to go in and set the halving clause to show only groups having a count of greater than 2. So this is something that you couldn't do before, and now it lets you not just query across individual events, but filter across groupings of events. Doesn't that graph look a lot cleaner? So now we can see that there are a couple of customers that have been querying us and have been still seeing successes, but it's only one customer that is seeing consistently slow performance and is seeing consistently more queries. We can also confirm this hypothesis by going into BubbleUp and highlighting a specific area that I want to look at rather than trusting Honeycomb to only show me the queries that have a failed service level indicator. So that enables me to do my own exploration and digging and have Honeycomb hint to me proactively with its machine smarts what fields I might want to look at. But let's also share what I know as a human. Let's share that with the rest of my team by describing the query and saving it so that my teammates can see this behavior in their query history. So by doing that, I've saved the results in our shared lab notebook so we can all look together and see what queries have we all run and which ones have been annotated with titles. And then I can go in, or my teammates can go in, for instance, my teammate who's on call, and they can see in team saved queries what queries that I ran and named. So this really helps us as a team debug issues faster because we're all able to understand what's going on in production together. But let's go ahead and dive in a little bit more and have a look at an individual trace exemplifying the slow behavior. So we can see here that this is a query that is not just buffering and is sat in a queue for 2 seconds. We are actually spending 2 seconds of time in AWS Lambda, as well as in the parent process of Retriever, which is our storage engine. So this user is not just hammering us with a lot of queries. Their requests are taking a lot of time, and that time is actually spent chewing on doing that computation. So we should probably verify that the system as a whole is behaving well. So we're going to need to go back and have a look at the system holistically. So let's go ahead and have a look first at which hosts are most negatively impacted by this change. So we can see here that some of our hosts are perfectly healthy, but that there are 3 particular hosts that are seeing a high number of errors being returned and high latency. So we could, for instance, at this time, filter just that individual host name, as well as being able to filter by dataset and so forth. But in this case, what I'd like to do is show the metrics for my entire system together. So we can see the CPU of all of these retriever workers and the memory of all of these retriever workers, as well as a metric from AWS, the number of concurrent Lambda executions. So I can go ahead and do something like roll over an individual line to see what the behavior is of that individual host name. I can also dive in and look and get an understanding of how that host name's behavior differs from the other hosts just by rolling over and comparing. But if I need to see things in more detail, I can, for instance, click on any of these graphs and I can see the graph blown up to full scale. And it's not just Lambda executions. I could have picked any number of CloudWatch metrics that I wanted to plot here that are automatically ingested into Honeycomb. So let's filter to just this individual hostname that's behaving slowly. And then let's go ahead and apply that query filter. Let's go ahead and filter specifically to that host to understand what's the CPU utilization of that host. So the filters and groups are reflected here, and that allows me to quickly understand everything that's happening all on one screen. So overall, we can see that since we deployed the shorter caching, that each of these queries is running and consuming CPU on the host and on the Lambdas. So that means that we need to do something to address this, because this one customer is really slamming us in production, and we didn't anticipate or see this in pre-production. So now is an opportunity for me to go back to my SLO and try to put a stop to this behavior before we burn through all of our SLO. So this set of users is having a hard problem. So let's go ahead and go into Launch Darkly and turn off this user so that it stops impacting production. So we're just going to go ahead and flag this user off for now, and that way we'll stop burning through our error budget and we'll be in a lot better shape. So looking at this change, you'd think that it would be such a simple change, but turned out to have such large ramifications on my entire production system. So that means that I need to go ahead and make sure that I'm mitigating the impact of what I do. And that way I can go ahead and take my own time fixing the overall issue. So now that we've mitigated the issue by turning off this user in Launch Darkly, now we can go ahead and think about what we were able to do using Honeycomb. So Honeycomb enabled us to catch this issue before it burnt through our entire error budget and allowed us to debug and understand what was happening. In this case, that the user's queries were suddenly no longer being cached and therefore were being allowed to execute against a real live storage engine 50 times more often. Instead of executing once every 10 minutes, it was executing once every 10 seconds. So that's really part of what the power of Honeycomb is. So Honeycomb allows us to understand what's happening in production, and it enables us to understand how those changes impact customer experience. We can make design decisions like whether query cache duration should be a fixed setting or whether we need to make that logic adapt to the query workload size of each customer. So this is what it means to give developers fast tools that fit our needs so that both operations and development concerns can be understood from the same interface. So at Honeycomb, we've reimagined the experience of deploying to and debugging production. And using these same approaches, your teams too can work together to release features quickly and reliably with Honeycomb. And you can center around doing what you do best, building customer experiences that will delight your customers. Thank you very much for your attention and enjoy the rest of Honeycon.
Holy cow. Good thing we're all posting all these videos later, so you can pause and rewatch that at your own pace. Same Honeycomb bones, a whole lot of new look. We have a lot to announce today. First, as you saw in that demo, we have a new query builder experience. That's available to all Honeycomb users starting today. For the longtime Honeycomb users out there, I hope you're as excited to see autocomplete for filter values and time over time comparisons as I am. For the power users out there, you get a new halving clause that filters on aggregates. Being able to group by high cardinality fields is great. Being able to filter on the grouped output to exclude or surface outliers is better. And I'm personally thrilled about our dramatically improved keyboard friendliness. From a set of keyboard shortcuts to respecting undo and redo commands to all around better keyboard-driven UX. Second, at the core of Liz's story, you saw her debugging a new feature we've been developing. Starting today, in open beta, we're announcing our full query data API so that users can fold the ability to quickly and flexibly query over high cardinality data into your workflows. Observability and Honeycomb, it's better with friends. So we can't wait to see what creative solutions you all build with this API. And last, but certainly not least, today we are announcing Honeycomb metrics. Now, If you've followed Honeycomb, or Charity, or Liz, or me, or anyone from Honeycomb for a while, you know that we've typically taken a very firm stance against using metrics for debugging. For a long time, we resisted building metric support into Honeycomb because when all you have is a metric and a dashboard, every engineering visibility problem seems solvable by adding another time series. And when it's 10 times easier and 100 times cheaper to track infrastructure and CPU metrics rather than application logic and high cardinality businessy metadata, people will choose the quick and easy rather than the thing that's hard and right. And in doing so, limit themselves to the technical constraints of the past. So 5 years ago, we focused Honeycomb on what wasn't yet possible: a fast exploratory approach to engaging with rich, wide events containing high cardinality data and connecting engineering concerns with what matters to the business. We think we've done pretty well at that so far, because at our core, Honeycomb is all about context, helping surface the right information in a graph, table, or visualization to help you, the human, understand whether a signal matters. Everything we build is meant to provide layers of meaning, not produce data silos. What I love most about this approach is that we're redefining what it means to have metrics data sitting alongside observability data. Observability is best suited to understanding how customers experience the code you write. It drives curiosity, and it gives developers and operations a common language to understand how business problems unfold in production. Fine-grained observability data is the best way to understand what's happening in your applications. But not all engineering visibility problems are solvable by adding more fine-grained events. We know this. Sometimes the systems you care about won't let you capture that level of fidelity. And so aggregate measures like metrics help build a bridge between understanding what's happening in your applications and understanding everything else that surrounds running those applications, like infrastructure or your runtime or anything else that constrains how well your code runs, but doesn't actually help you understand the behavior of the code itself. To focus on creating an unparalleled way to understand application behavior and production, we swung the pendulum hard in just one direction. But we know system-level metrics still hold value. By making you go see those in another tool, we had been asking you to carry context in your head, to connect disparate parts of the whole on your own. So now it's time for the pendulum between dev and ops to swing back. No more jumping between the tools and trying to piece together the whole picture from multiple sources of truth. Honeycomb can now be the source of truth about production and the center of gravity for your engineering team. We have a bigger story to tell, and I'm sure you can't wait to hear more about how it works. You can hear more about how we're approaching the metrics world by attending 2 breakout sessions in the Honeycomb product track. At 9 a.m. Pacific, check out Alalita Sharma's talk on building metrics into OpenTelemetry. Then, immediately following that session at 9:30, you can hear how, at Honeycomb, we use that work to get metrics into Honeycomb. Those are 2 deep dive sessions you won't want to miss if you've been waiting to get metrics alongside your observability data. The customer experience is ultimately what matters to your users, your business, and your team, whether you are dev or ops. And a wise ops engineer once said that 9s don't matter if your users aren't happy. And when your users aren't happy, the best code in the world can't figure out why. It takes that curiosity embedded in excellent engineering teams and aligning those to serve customer needs. That's the promise of observability that we are here to deliver on. Later today, we'll hear from a range of different teams using Honeycomb, telling stories about how they've incorporated observability into their day-to-day. But first, I'd like to shine the spotlight on a very impressive engineering leader, Rich Anakor, Chief Enterprise Architect at Vanguard. Because observability and leading edge practices aren't just for the unicorns of the tech world. Vanguard's business is all within a highly regulated industry where big change can be incredibly slow. But they've been able to use Honeycomb and OpenTelemetry to drive a lot of change incredibly fast across a very large enterprise team. They've changed developer workflows, and thus the relationship that development teams have with production services. And they've done the human work to ensure that all of their engineers can understand the layers of complexity introduced as part of this modernization initiative. Here's Rich to share more about Vanguard's journey with Honeycomb.
Hi, everyone. I'm Rich Anakor, and I'm from Vanguard. Today, I'm going to talk to you about Vanguard's journey with OpenTelemetry and Honeycomb. I'll talk to you about this in 3 ways. I'll talk to you about how we got started. I'll also talk to you about where we are today. And I'll talk to you about where we're headed. And more importantly, also, I would hope that this serves as a template for organizations our size, and also for organizations in highly regulated industry, like the financial service industry. So to build context around this, several years ago, Vanguard had this idea to move all of its workload from our data centers to the public cloud. The idea was this transformation will happen sequentially. So we would move from our data center to a private cloud. From the private cloud, we would go to the public cloud. What happened is we ended up in a state where we were running across these 3 environments simultaneously. So we had services that had dependencies across the 3. So this layered in so many complexities for our support teams to really understand what's going on in our environments. So I joined Vanguard about 2 years ago, and my job was really to help build instrumentation and build out the telemetries that would help our teams really know what's going on in the environment. So we set up goals, and these goals were about how can we support our applications with these layers of complexity? How can we know what's going on in them? We needed an approach that will help us understand this modern production environment. We knew that our current APM solution did not scale. It was not really bringing that engagement from our teams. We knew we had to solve this problem. So how did we get started? So the one thing I want to highlight about how we got started in this journey is that we started really small. Starting small is really a great technique that I think teams should learn from. I come from financial services, been there for more than a decade. And one thing that you see is things like this will require approvals, require so many organizational involvements to really get an idea off the ground. In this case, that was not the case. We're only 3 of us, myself, an engineer in my team, and another engineer in one of our feature teams. So we came together, we knew that our current approach did not scale. What can we use? What technology solutions are available out there that can tell us the patterns that are happening as calls are going from our data center to the private cloud, to the public cloud, and traversing back and forth? How can we see this? How can we really help our teams reduce mean time to recovery? So this was a goal that we set. So now what did we do? We knew one of the technologies that was top of mind was, okay, we need to use a distributed tracing approach. So we started looking at technologies out there. Open tracing came to mind, but we needed a backend where we would send these trace information and be able to interrogate our systems to see what's going on. We looked at all the vendors. Honeycomb became a partner who wanted to work with us along this journey. So we started really small, as I mentioned. We took one of the services that had dependencies across these environments. So how did we get started? It was a quiet team, small team, self-organizing team. We started the instrumentation. We were able to get early feedback. We were able to see what's happening. But we did this initially with Beeline. One other approach that we wanted something that was vendor neutral. We didn't want our engineers worrying about licensing, what vendor agents were installing, and all of that stuff. So we went with open tracing at the time, but open tracing didn't give us that other instrumentation capability we were looking for. We knew about OpenTelemetry, we knew about the progress that was happening in that community, and we said, let's try this out. We brought in OpenTelemetry. Honeycomb did not care. They were like, whatever you use, our backend can handle it. So we started with OpenTelemetry. So with OpenTelemetry, the auto instrumentation was one of the main drivers that really helped us. We were able to propagate context across application boundaries, across environments, and we were able to interrogate these systems and really understand what's happening. So let me tell you a bit about where we are now. As we moved, we have hundreds of teams now using OpenTelemetry and Honeycomb. We're able to bring a different mentality in the way we run and manage our production systems. We're able to really help our engineering teams. We've changed the culture. And one of the things I will highlight today is how we think about production systems. We often think of APMs as something that is only used in production, or we use it to fight fires. We use it to respond to incidents. With OpenTelemetry, we found, yes, it's actually very effective in doing that, but also it helps you to do analysis. So I'll highlight two examples. One main example that we found, our team discovered, was there was a migration effort going on. And this team wanted to move some data to a new repository in the cloud. And they wanted to know all the dependencies that were involved. They wanted to know all the user actions, how they map back to these backend stored procedures. So they've been going months with spreadsheets, looking at code, involving really smart people, engaged in trying to solve this problem, but they could not. Because this was on-prem, this was considered a legacy application, they did not think we could help. This application had dependencies with other workloads in our private cloud. But we said, okay, let's try this out. With OpenTelemetry and Honeycomb, they were able to answer these questions within minutes. So that was key. It just showed our teams that this is beyond just responding to an incident. You can actually understand how your systems are behaving. Another important thing that I want to highlight today is when it comes to measuring what's happening in your production systems, really measuring what matters. So I'll talk about service level objectives and the impact it's had in the way we manage our production systems. One example I would like to highlight today is a testimonial from one of our teams. They had an SLO defined for a critical service. They actually got notified through their burn alert that they had to respond, and within 30 minutes, if they didn't respond, there would be a customer impacting issue. They were able to respond. They were able to figure out what the issue was. They were able to remediate this issue before it became customer impacted. So these testimonials have energized the teams. We've had a mandate as we speak that every single application in our environment, any new service that is being built, must be instrumented with OpenTelemetry and reporting traces to Honeycomb. So these have really changed the way we do business. It's changed the way our engineers work. It's changed their engagement. It's made them more productive. So now where are we headed with this? As we're making these mandates, I think it's important to connect the journey. So we've set some goals. I'll talk about our year-end goals. One of our year-end goals is that we wanted to move 100% of all our applications to Honeycomb using OpenTelemetry. That's a difficult goal, but one that I'm confident that with the level of engagement we have from our teams, that we'll be there by year end. One of the things that we want to call the culture that we also want to imbibe is to really drive down mean time to resolve. And how do you do so? You do so by really knowing when there is a problem. And that's one. Two, knowing where the problem is. And three, knowing how to solve them. While OpenTelemetry is not something that's directly resolves the issue you have, but it gives you that power. And using Honeycomb allows you to slice and dice this data the way you want to see them. And that's the goal that we have. We want to reduce our MTR significantly. So this is a really, really powerful thing that has driven value and what every stakeholder in the team have come on board. We no longer have to convince teams that this is a good thing. Everybody wants to join this movement. So one thing that I want to leave you with, this thought. For organizations like ours, I keep saying that because that's where I spent most of my time in companies like Vanguard. This might seem like a difficult journey to embark on. I think it's important to start small. It's extremely important to celebrate the small wins. And above all, engage the right people early. That's what we did. these three things. The success really comes with the result. People are going to get engaged when they see value. There are always questions that people have about their systems, but they cannot answer them. When you give them the avenue to answer these questions, it becomes extremely powerful. That movement is something that I've seen at Vanguard, and we're excited about where we're going, and we're excited about learning more and sharing with the community as we make progress. So all I'm leaving you with today is to really, really think about your current situation. Think about the challenges you have about your system. Think about what are those questions that you want to ask your system that you don't have answers to. Maybe tracing is a good way to look at it. Maybe OpenTelemetry can help you. And maybe Honeycomb can help you. So this is the Vanguard story, and I hope to continue to tell this story as we make more progress. If you have additional questions, my contact information is available. Feel free to reach out to me directly and ask about our journey. I'll be very happy to share what information that we have. All right, thank you so much for listening to me, and I hope you have a great day. Thank you.
I've been talking about her all throughout this keynote. Now I'm delighted to be joined by Charity for some reactions to that story. Charity, what did you think about how Vanguard is using Honeycomb to change developer workflows and their understanding of what's happening in production?
It's pretty exciting to see people like building their careers on making their lives better and the lives of their coworkers better. Like, this is what we had always kind of hoped and dreamed, and it's really astonishing to see. You know, like, I've never worked in a big company like Vanguard, you know, that was trying to make this sort of like quantum leap, and it's just so exciting to see it actually happening.
I love that Rich emphasized start small, right?
Yeah.
Especially at a big company, it feels there's such a temptation to be like, we have a huge initiative.
Yeah.
The whole thing, we're going to do it all at once.
Yeah, and you do have to like you do have to like have that buy-in, I think, but also we're engineers. We need to be shown. We need to be proven. You know, like nobody can. It's kind of like, you know, the old Google saying that you can only plan for something that's an order of magnitude bigger than you have now, right? Like, you can't plan for the whole thing. You can have a hazy idea of the outcomes that you want to achieve, but when it comes to actually implementing it, yeah, you have to start small, celebrate the small wins. What I really thought was interesting was he said, engage the right people early. Like, what do you think that means?
I mean, it's kind of like what you and I talked about early on, right? You've got to get the people who are feeling the pain, who are currently fighting the fires, but there's also that kind of pulling of, hey, you build it, you own it. What does this look like? It's not scary.
I think anyone who feels strong ownership over the systems those are the people who have to get on board. And sometimes it's the managers and execs. Sometimes that's engineers on the ground who aren't even the most senior. Often it's the most senior engineers, but like people who care deeply about their work. You know, they're not going to. They don't want to just come to work and do a checklist, right? They want to make things better. So you need to show them that it's better. I like the range between experiment to mandate. At some point, you do have to have a mandate, right? But you have to like prove yourself through the experiment so that people want to jump on board with you and come with you where you're going.
There's a real thread of like fear through this, right?
Yeah.
Reducing fear. Hey, look, it's an experiment. We'll try this out. Hey, we've got this burn alert. Things aren't bad yet. And it's
because people have a system that works. It's good enough, right? It's good enough. You're making money. Your salary is safe. You know, it's good enough. And there's a real like, who wants to rock that cradle, right? You hear that it can be better, but can it? You know, you're taking a lot on faith, I think, and that's why I think it's so small to like show your work as you're going.
Yeah, that burn alert story is again like, what a win! What a win to get to fix something, deal with something before the customer impact.
Before your users are upset.
Mm-hmm.
Like, that's what makes you feel like SLOs are like precondition, right? Like when they're done well, it's like, what is that movie that it's from where you have the precogs?
Minority Report.
That's the one, right? Yeah. You have a sense, you know that people are going to be unhappy, but you've got a time window where you can actually affect the outcome. And it's so great because, you know, if you've adopted the SLO story, then you also set down the burden of alerting on every single spike and ding and CPU and, you know, like all the symptoms. which is what burns people out. This is why people don't want to be on call for the systems. It's not because they don't want ownership. It's because of the long history we have of masochism, of just like, we're going to follow this grenade. If anytime anything wiggles, wake me up. Like that doesn't work when you have this giant, massive, distributed global system anymore.
Yeah, I really enjoyed the kind of growing drumbeat of the human factors conversation. That was, there were a few people talking about it back in 2015, 2016. And it feels like with the rise of our SRE, people are, it's all about burnout and fatigue and how we avoid that and how we use the tech that we have, but make
using
it better.
Observability to shine a light on the dusty corners of the system that aren't working well, that are tripping everyone up. I really like that. I also liked, and of course I would, because, they're talking about partnering with us, but like, I like the admission that you don't have to have all this expertise in-house when you start, that you can partner with people like Honeycomb who have fought this battle before, who are willing to jump into the trenches with you. Like, it's not that we have all the answers, but we see part of the story and you see part of the story, and together, like, we can figure it out.
There's something really special about, and maybe this is right, our industry is so based on
apprenticeship,
sharing knowledge, helping each other, learning from each other's successes and failures.
Yeah.
And I am grateful and humbled and determined to keep.
Not everyone can have Liz Fong-Jones on staff, but you can rent them. You can rent the Liz Fong-Joneses, right? And the work that Liz and others here have done to like, it's one thing to solve a problem once. It's just like I wrote that post about being a senior engineer. The difference between knowing your system and being a senior engineer. One is just your experience, and one is like being a senior engineer. I didn't put that very well, but like one is knowing your system and your specific system, and it's the next level is being able to extrapolate and to be able to repeat that and to be able to like bring the entire industry up. One service, one system, one team at a time.
And with that, we end today's keynote and start our breakout sessions. There are 2 customer tracks you should check out from here. One track focuses on customers sharing practical lessons from what they've learned throughout their Honeycomb journey. The other is all about different mysteries that customers have solved with Honeycomb and how they've been able to use the product's various capabilities to better understand their production environments. There's also a Honeycomb product track that includes not just these deep dives on metrics, but also shares best practices for incident response and cover our strategy with open telemetry and instrumentation. If you have any questions or comments, or to find out which sessions are happening when, check out our website, or be sure to ask in our Pollinator Slack in the hnycon Honeycon channel. Thank you all so much for joining us on our inaugural Honeycon Day. We're all here, developers and operators and DevOps folks alike, to build great customer experiences. And we at Honeycomb look forward to continuing to partner with you all on our grand observability journey. Please enjoy the rest of your day here.